again today. It's just really nothing but triangles. Now, these are on your yellow sheet, and I'm going to use these today. So that's why I have them up here specifically, just so you kind of know which ones I'm using. If you look on your yellow sheet, just to kind of point it out too. So we're going to start using some more of the reciprocal, those we've been using at the top. Some of these quotient we've been using. These Pythagorean ones, haven't seen yet, we're going to talk about those. If you flip it over to the back side, those are on the back side at the top. Now, if you look under Pythagorean, it makes my eyes almost hurt looking at it. There's 9 of those listed under Pythagorean, 9, which I just find kind of super duper obnoxious, if we're going to be honest. I can show you, that's the next thing I'm going to show you here. I can generate all 9 of those off one equation, okay? So, because I'm that good, right? And so are you. So I'm just going to, show you how you can generate all 9 of those off one equation. Because let's get real. I don't want to have to memorize all of that stuff. Because eventually, next semester, the first chapter, we're going to have some of this yellow sheet memorized, and you'll be getting these very fun-filled identity quizzes. Just for fun, I just gave one today in Trig Pre-Calc, very similar. I'm going to dig one out here for you just to show you. Oh gosh, maybe not that one. That's an 8 out of 20. Nobody wants to see that. Well, here's a 20 out of 20. So you can just see you're going to start doing things like this next semester. They're going to fill in reciprocal, quotient, even, odd, cofunction. We're going to start next semester doing some different things like that. And again, reciprocal and quotient, we're just going to use them so much that you'll just have those down. That's not going to be a big deal. Even, odd, little sign change. I can make those easy on you. Same on cofunction. The Pythagoreans get a little, to write all those down. So I am going to show you how you can do it off one equation. So if I'm working on these and I'm like, oh gosh, I don't know all 9, this is the one I work off of. This is the most important Pythagorean identity. So underneath there where you have a little bit of room, I put myself a whole nice slide here for it. I can show you how to generate all those Pythagorean identities, all 9 of them. I'm not going to bore you to tears and do all 9, okay? Nobody wants to see that. But I'm going to show you how you can do it all off the sine squared plus cosine squared. So I'm just jotting that down so it's in front of me. So if you look on your yellow sheet, some of it is they just manipulated this equation, meaning they solve for sine squared. They subtract sine squared off. So if you look under Pythagoreans, they have 1 minus sine squared equals cosine squared, whatever. Cosine squared, they subtracted sine squared off, so on and so forth. Now, to get to the other ones, the ones that have tan, cotan, secant, cosecant, here's how you can generate those. I'm just going to, again, manipulate this equation. Just because I feel like it, I'm going to divide by sine squared. Now, I have to divide everything by sine squared. Because, of course, I can't just divide part of the equation. I have to do all of it. Now, here's where these are going to fall into play. Of course, this is 1. Cosine over sine, that's an identity we started using more yesterday. If you look under quotient on the front, cos over sine is cotan. We're just in a squared form, so I'm going to throw a squared on it. We have used 1 over sine. That's on the front under reciprocal. 1 over sine is cosecant. We're just in a squared form. So, of course, yours are in front of you. I'm going to click it back a slide. So I just made you this equation here, okay? So I don't memorize all 9 of those things. I just work off that first one. Now, to get the other equation, let me start back so I don't make a mess here with my original sine squared, cos squared. That is a very messy squared. So if I divided the other side by sine squared, what do you think I'm going to divide this time by? Cosine squared. So it's just manipulating that equation. Sine over cos, we know that's our quotient identity. We've used that. Sine over cos is tan, but we're in the squared form. Cos squared over cos squared, 1. 1 over cos we know is secant from our reciprocal identities on the front, but we're in the squared form. So that is how you can get this equation. Tangent squared plus 1 equals secant squared. It's just manipulating that equation. I can get everything, all of those Pythagoreans, off that one red identity. Do I have kids that memorize all 9? Sure, you can memorize them all. But again, I think that's irritating because there's so many things on there. There's some other things you might want to just straight memorize, which we'll get to eventually. But I just wanted to show you how you can generate them all off one equation, just to make it hopefully a little easier on you. All right, we're going to use some of those. So expressing one trigonometric function in terms of the other. So it says express sine of theta in terms of cos of theta. Okay, we got it. Express sine of theta in terms of cos theta. So let me go back a couple slides. So like I said, I'm kind of looking off of our identities here, the ones we're most commonly going to be using today. So I'm like sine theta in terms of cos theta. So I see this has sine and cos in it, so thinking I'm using this one. I do see this has sine and cos in it, but it also has tangent. You can only have like sine and cos, so I can't have tangent according to the directions. So I'm looking at this equation, that sine squared cos squared equals 1. I'm going to see what I can do with that. So let me just jot that down first. Sine squared plus cos squared equals 1. So it says express sine in terms of cosine. Oh, I just need to solve this equation for sine. I just need to get the sine by itself. Okay, I can do that. I'm going to subtract cosine squared off. Now, I don't care if you put negative cos squared plus 1 or 1 minus cos squared, whatever. And I know you know this. What cancels squaring? You need a what? Square root. So I'm just going to square root everything. So sine of theta. Now, we are solving for a squared, so don't forget your plus or minus. And then not a lot I can do here. If this was product instead of subtraction, you could apply the radical to everything, but it is subtraction, so clearly I can't do anything else. Do I have sine in terms of cosine? I sure do. Circle it, we're done. So just manipulating some of those equations. Okay, so express tan in terms of sine. We'll deal with the thetas in quadrant 2 at the end. So I'm back to those identities. Tan in terms of sine. Well, I'm not going to use this because it's got cotan. That's a fail. So I'm looking what else has tan in it. This guy. This has tan in it too, but it's got secant, so I'm not feeling that one. So I think I'm probably going to work off of this one because clearly that's got our functions in there that we're going to work on. So let's see what we can make happen. So I have tan of theta sine over cos. Okay, now I'm like, oh gosh, I'm still working, because in terms of sine, so that means I need to do something with this. I need to do something with the cosine. We need to replace the cosine with something. So, looking at back here again, I'm going to use this because sine and cosine are related here. I can solve that equation. I can rewrite that. I can solve it for cosine. I can subtract sine squared off and solve it so I just have it one trig function. So I'm just going to jot down that equation again, that sine squared. I feel like I've written it 10 times today already. And I want to swap out that cos of theta. I want to substitute something in. So I'm going to solve this for cos of theta. I'm going to subtract sine squared off. And then, of course, we would root it. So I'm going to replace, I know I need the plus or minus. Bless you. I'm going to talk about the plus or minus. Okay, so I'm just going to use a plain old boring substitution here. I'm going to take this and substitute it in here for cosine. Because we want it, of course, everything in terms of sine. So I'm going to rewrite this. This is why I left a little space there. I've got my sine on the top still. And I'm going to fill in that crazy blue looking stuff on the bottom. So I'm like, okay, great, my answer, it's just got sine in it. That's the only trig function, winning, winning, winning. We need to talk about that quadrant too. Because it's not going to be this time both plus and minus because you have a specific location. So that affects the positive or negative. So I'm thinking, of course, quadrant 2, We all know where quadrant 2 is, right? And I'm thinking about my all students take calculus. Everything's positive, sine positive, tan positive, cos positive. So the question is, if we are in, I'm going to circle it for dramatic emphasis there. If we are in quadrant 2, what is the sign, S-I-G-N, the positive negative, for cosine? Is cosine positive or negative here? That's what I'm really asking you. Positive or negative for cosine? Negative, because cos is positive here, A and C, negative over here. So I'm just going to, in my final answer, use the negative. I'm going to take off the positive. Now, because I'm running out of room, I'm just going to kind of try to not erase everything. Okay, try to put the negative in front. Now, this is just me being nitpicky. That bothers me just a little bit. Normally, we don't leave a negative in the denominator of a fraction. So I'm just going to kick the negative out front, just because it looks a little nicer, and I'm clearly running out of room. You don't have to rationalize or anything else. You just have to rewrite it so you have sine only in your final answer. So that one was a little crazy for sure. First one nice and easy. We just had to solve, of course, for sine, little subtracting, square rooting. I kept plus or minus because I didn't have a specific location, so it doesn't matter. That quadrant 2 is where I had to figure out cos was negative in there, and that's why I used the negative on that one. That's probably the trickier problem of the day, just for the record, because this is super easy. I like when they tell you what quadrant you were in. If tan of theta is 2/3 and theta is in quadrant 3, find cos of theta. Okay, all right. Well, let's draw a triangle in quadrant 3 to start with. Now, just because I know I'm in quadrant 3, this is just me kind of skewing the graph a little bit. I'm just going to kind of draw a big quadrant 3 here, because I really don't care about the rest of them all that much since I'm in 3. I'm going to make my right triangle. Now, of course, I don't know if it's 30, 60, 45, any of our special triangles, probably not any of those, which is totally fine, because remember, cosine, you're comparing sides on the triangle. It's all about the sides of the triangle, not the angle. The angle doesn't matter right now. You know tan's 2/3. So, of course, tans are TOA, opposite adjacent. Opposite 2, adjacent 3. Now, due to being in quadrant 3, though, I'm going left and down. Do either of those sides need negatives? Oh, yep. Which is okay, because 2 negatives make a positive. That is still equivalent to positive 2/3. Now, final answer I want from you. I want cosine. So I want adjacent hypotenuse. So I'm like, oh, crud, okay. Well, I got to do a little bit of work here. I've got to figure out my hypotenuse. What magical theorem are you using to find your hypotenuse? Pythagorean, yeah. So -2 squared, -3 squared, hypotenuse squared. So I'm going to have 4 plus 9, 4 plus 9, we got it. And we're going to root it. Okay, so adjacent -3, hypotenuse root 13, and I'm just going to rationalize for a final answer. So this is, think about your quiz. So this is, technically not on your quiz tomorrow, but there were some very similar problems to this also yesterday. So kind of, sort of. I mean, we should know how to use Pythagorean theorem. That was from yesterday, we should know that. We should also, of course, know our SOHCAHTOA. So kind of, sort of, is on your quiz, isn't on your quiz, sort of thing. All right, kind of more of the same. Are we ready? Am I out of order? I'm not out of order, am I? I might be mislabeled. No, we're good. If secant of theta is 2, it's in quadrant 4. I just cringe because you need the other 5. Okay, so we got to write a lot of fractions. All right. Quadrant 4, so kind of like the last one, I'm just going to draw kind of a big quadrant 4 here. Since they specifically tell you where you're at, who cares about the other quadrants? Right angle always with the x-axis. We don't know if it's a special angle. Who cares? We're all about the sides here. Now, I don't like necessarily that they gave you secant. We like to work in our main 3 trig functions. If you know secant is 2/1, I know cosine is the reciprocal. Plus, I need to find the other 5. Well, there's one of them. Okay, so now I can label the sides. Cosine, adjacent, hypotenuse. Again, I'm thinking, oh gosh, I gotta use Pythagorean theorem, but I don't. Because these are sides on one of our, if you can see the little baby triangles written down there, on our special right triangles. This really is which special triangle? 30, 60, 90. Not that I care about that today, I care about the sides, but it's making my side work easy. So 1, what's the other side? Square root of 3. You could do Pythagorean theorem, but why? That's too much work. The only thing I would say is I would throw a what on that square root of 3? Negative, because we're going right and down. Okay, now you have all the sides. Yeah, it's 30, 60, 90, but who cares? They want all the ratios of the sides, all the trig functions. So I've got cos and secant. All right, let's do sine and cosecant. So sine opposite hypotenuse. Cosecant would be the reciprocal of that. Of course, I got to rationalize. So much fun on the rationalizing. Okay, and then let's do tan and, of course, cotan. So TOA, opposite, adjacent, negative root 3 over 1, or negative root 3, right? And cotan, we got to flip it, negative 1 over root 3, and rationalize it out. 1, 2, 3, 4, 5. Okay, we got them all. Just double checking my math that we counted them all. So any questions on that one? So again, not technically on our quiz tomorrow, but kind of, because we've done a lot of this already in the A part. Making the triangle, getting the missing side with Pythagorean theorem or your special right triangle, and listing out all of your fractions. I feel like we're just doing more and more triangles. Okay, this is really the right example. I just mislabeled it. We're on 4, my friends, 4. And then obviously 5. Okay. Find 2 solutions of the equation. Interesting. Give your answers in degrees and radians. Okay. All right. Do not use a calculator. Okay. All right. Well, 2 solutions. So my first question to you is, what am I solving for? What's your variable? Theta. Solving for theta. Theta represents an angle. So now I am asking you, what are the angles, plural, that have a cos of square root of 2 over 2. Now, I see that square root of 2, and I'm instantly thinking, which special triangle? 45. And we have to figure out which two solutions, 2 answers, which 2 quadrants we're going to draw in. So now I'm thinking about my all students take calculus. So because I'm going to draw some triangles, I'm going to do my little all students take calculus kind of on the outside here, so I leave myself a little room. And I see we have cosine for dramatic emphasis, positive, square root of 2 over 2. Which 2 quadrants is cos positive in? 1 and 4, so that's where we're going to draw. Let's start in 1. Now, we already said we saw that square root of 2 and we're like 45, 45, 90. And I'm just double checking. If I do cos of that red triangle, I've got adjacent over hypotenuse. Yeah. That's square root of 2 over 2 if I rationalize it out. What I care about is that our answer is the 45 degrees, the angle. And just because of the directions, they also want you to give it in radians. Well, what's 45 in radians? That one you probably know. Pi over 4. Do your pi over 180 if you have to. Now, we also said, just to mix it up here, color code it, we're going to draw it in 4. Now, I'm not going to get carried away necessarily and reinvent the wheel and relabel all the sides of the triangle. I care about the 45 because we're after the angle. Now, my second answer is not 45. I mean, how can 45 be in quadrant 1 and in 4? Okay, we have to make sure that we measure from 0 all the way around to quadrant 4. That is really how many degrees? 315. You're 45 short of a full circle. 360 minus 45, 315. What's the radians? Can you do it in your head? Now, if you can't, you know, you can always do your pi over 180. Or thinking about your quiz, God, I'm on fire today. What is radians of full circle? 2 pi, good to know, good to know. And your quarter pi shy, what's 2 pi minus 1/4 pi? 2 minus a quarter. 1 and 3/4, which I'm going to roll with it in proper fraction because that's how I'm doing it today. Got it. That wasn't so bad, wasn't so bad. Okay, so the key is, multiple keys. Which quadrants, plural, to draw it in, okay? Which special right triangle does it turn out to be? And make sure that you are always measuring, if you're out of quadrant 1, make sure that you are measuring from 0 to that location. Let's do another. Okay, cotan, I don't like that it's cotan. So right away, before I even start drawing, I'm like, gross, I'm just gonna flip it. I'm gonna do the reciprocal. We like to work in our main 3. Just makes our life a little easier. Yeah, I know that should be rationalized, but I'm not gonna do it because if you rationalize, you have square root of 3 over 3. Neither of our special triangles have a side of 3. So I'm not gonna put it in the rationalized form. I'm gonna roll with that and try to figure out where to draw. And right away, square root of 3. Are you on the 45, 45, 90 or 30, 60, 90? 30, 60, 90. We just got to figure out where. Students take calculus. Well, of course, the key, we have tangent being negative, which means I'm eliminating the A, because everything's positive there. I'm eliminating the T, because tan is positive and 3, we got negative. So process of elimination, I'm going to draw in 2 and 4. I'm going to start in 2. Okay, so we have tangent, of course, we know that's TOA. So opposite, adjacent. For the thrill of knowledge, our hypotenuse would be 2. More importantly, most importantly, what is your reference angle? What is the angle across from the side that measures 1? Is that the 30 or the 60? 30. Now, when I give my answer for that green triangle, I'm not going to say 30. 30 degrees is over here in quadrant 1. We have to measure from 0 around. You covered how many degrees? I heard somebody already say it. 150. You're 30 short of 180. And then, of course, you have to convert that into radians. I just happen to know it. All right, there's one of our answers. We have to go into quadrant 4 to the other. Now, we already know, we figured out from here our reference angle's 30. So I'm not going to relabel all the sides. I mean, you can if you want. This is what I care about. I mean, if you want to relabel the sides, do it, but who cares? I care about the angle. And I'm going to measure from 0. So you're 30 shy of a full circle. 330. Anybody got it in radians? 11 pi over 6. Got it. So again, I mean, it's technically not on your quiz tomorrow, but still the 30, 60, 90s, all students take calculus, still all kind of coming together, so to speak, on that. Any questions on that guy? Okay, last thing I've got for you today. This is so easy. Before I click it, let's go old school math. When you were in, I don't know, 7th grade, maybe 8th grade, what was the formula you learned for area of a triangle? 1/2 base times height. We all know that, right? Half base height. And plus, we all love geometry in here. And the room went quiet. Okay. All right, so anyway, moving on to that note. So half base height. The height, remember, makes that right angle in the middle of the triangle. You don't always have that, okay? So then I'm like, if I don't know the height, then I'm like, oh Lord, it's like a whole big trig problem. I gotta draw it in, I gotta use sine, cosine. It's super duper obnoxious. There are other formulas, believe it or not, that you can calculate area of the triangle. There's other formulas besides half base times height. So, area of a triangle. If you know the sides, A and B, of course, and the included angle. This like geometry. Included angle, the angle in between the sides. So 2 sides and the included angle. If you know that, you can use this very lovely formula. 1/2 times the side, so I'll multiply between it, times the sine of your angle. There's another formula, we'll get to it in another section, called Heron's area formula, if you have all 3 sides. So you don't have to be like, oh, let me draw in the height, and let me try to use like SOHCAHTOA or some crazy stuff here to find it, so you do my base height over 2. Too much time. Short and sweet. 1/2 times the side times the sine of your included angle. All right, this is example 5. So, find the area of the triangle. No base height over 2 needed. I don't have the height, I don't care about the height. I'm going to use our new formula, 1/2. Times the sides. I don't care if you do 10 first or 3 first, whatever. Times the sine of the included angle. Now, good. I hear the calculator's coming out. Get your calculator out, because I'm going to have you punch it in. I mean, I know what the answer is. But, before you start typing it in, should your calculator mode be in radians or degrees? Degrees. Our angle's in degrees. Do a little double checky that your mode is in degrees. It'd be super sad to get it wrong because our mode's in the wrong thing. Nobody wants that. Round to whatever. I went to the whole. Surprise me. You should have it. What do you got? 13. I'm going to get fancy and put a label on. Centimeters squared. Got it. So, old school days, I would have had to draw in the height. I would have tried to use some trig, lost sines and cosines, which you haven't learned yet, to find the height. And it would have taken me forever. So, that is why we like to show you there are other options. Okay. Now, of course, I'm going